Assalamualaikum and a very good day. Today we are going to have a look on how to graph trigonometric functions. Before that, we need to recall a bit on how to convert angle in degree units to radian. For example, if you have 90 degrees, this is just equals to 90 times with pi over 180, which is just equals to pi over 2 radian. Okay. So whenever you want to convert angle unit in degrees to radian, you just need to multiply with pi over 180 degrees. For example, if I want to convert 270 degrees to radian, means that 270 times with pi over 180. This is just equals to 3 over 2 pi radian, or 3 pi over 2 radian. Okay. One more example. 180 degrees is just equals to 180 times with pi over 180 degrees. So we can cancel out that. Leaves us with pi radian. Okay. So that is if you want to convert degree to radian. If you want to convert from radian unit to degrees, for example, if I have 3 pi, this is just equals to 3, sorry, if I have say over 3 pi over 2 radian, this is just equals to 3 pi over 2 times with 180 degrees divided by pi. So it leaves us with 270 degrees. So whenever you want to change from radian to degrees, you have to multiply with 180 over pi. One more example. Say I have, pi over 4 radian. Again, from radian to degrees, we need to multiply by 180 degrees over pi. So pi over 4 times with 180 degrees over pi. So we can cancel out that. So this is just equals to 45 degrees. Next, sketching graph of trigonometric functions. In your syllabus, we are going to have a look at 3 types of graphs, which is the sine function, the cos function, and the tangent function. Okay, in general, for all these type of graphs, for sine function, we have y equals to a sine nx plus b. That is the general form. For cosine function, we have y equals to a cos nx plus b. And for the tangent function, we have y equals to a tan nx plus b. Okay, what is a? A is the amplitude, which is how high or how low your graph is. How about B? B is the shift. If B is positive, means that we need to shift up. The graph needs to shift up. If negative, we need to shift the graph down. Okay. And N is used to determine the period of the graph, okay, to determine the period of the graph. So again, A is the amplitude, N is to determine the period of the graph, and B is the shift, and it applies for all three functions except for tangent. Actually, amplitude for tangent does not really matter. We are going to have a look on that fact later. Now, for the three types of the graph, for function, sine theta, this cycle for sine theta looks like that. For cos theta, it looks like that. And for tan theta, it looks like that. Such that the dotted lines is the asymptote. Okay, so this is one cycle. And the period for sine theta is 2 pi over n. For cos theta is 2 pi over n. And for tan theta is just pi over n. Notice that tan theta has different period. And also I want to remind you guys, pi radian, okay, wait, 180 degrees is equals to pi radian. Means that 90 degrees is equals to pi over 2 radian. 45 degrees is equals to pi over 4 radian. And 270 degrees is equals to 3 pi over 2 radian. Sorry. And 360 degrees is just equals to 2 pi radian. It's good if you could remember this. If you couldn't remember this, you can always use the method that we discussed before. Now we are going to have a look at the graph of function of sine. Okay, generally the graph of function of sine is just y equals to a sine and x plus c. Okay, or you can put plus b or plus c. Doesn't really matter, but a here is the shift, the amplitude. Which means is how high or how low the graph is. And n is used to determine period of the graph. That is, the period is 2 pi over n, which means that one cycle in every 2 pi over n. And c here is the shift. If we have positive, means that we shift upwards. If it is negative, then it means that we shift downwards. Okay, before we start sketching the graph, let's have a look at the basic graph of sine. Suppose that we have y equals to sine 0. Sine 0 is just equals to sine 0 radian, which is just equals to 0 if you press your calculator. If we have sine 90 degrees, which is also equals to sine pi over 2, we will get 1. And if we have sine 180 degrees, which is just equal to sine pi radian, we will get 0. Sine 270 degrees, which is just equal to sine 3 pi over 2, we will get -1. And sine 360 degrees, which is just sine 2 pi, we will get 0. So basically, if we draw the graph, here this is y, this is x, and we have, say here is 360 degrees, 180 degrees, 270 degrees, this is 90 degrees, and 1 and -1. When x equals to 0, we'll get y equals to 0. When x is equals to 90 degrees, y equals to 1. X equals to 180 degrees, y equals to 0. X equals to 270 degrees, y equals to -1. And x equals to 360 degrees, y equals to 0. Basically, one cycle for sine graph will look like S. So this is just the graph of y equals to sine x, such that x is from 0 until 360 degrees. Okay. If the graph can continue, goes on like that, if we do not limit the x value. Okay, now let's have a look at the first example. Again, generally this is just equals to y equals to a sine nx plus c. And we know that in front of sine x there will be 1, because you cannot have coefficient a equals to 0, because if it is equals to 0, then everything will equals to 0. So you have to have 1. And also the value of n is also 1. So a is equals to 1, the period is equals to 2 pi over n, in this case 2 pi over 1, which is 2 pi, which means that 1 as in every 2 pi, or in every one cycle in every 2 pi, and our c is just equals to 0, so there is no shift. Okay. No shift. And we need to draw from 0 until 2 pi, means that since the amplitude is 1, so we label 1 and -1, and we have here is 2 pi, and obviously this is pi, 3 pi over 2, and pi over 2, and 1 as in every 2 pi. Okay, the keyword is 1 as in every 2 pi. So for every 2 pi, there will be 1s. Okay, so amplitude is 1. So the highest point is 1 unit, the lowest point is -1. So basically this is just the basic graph. And this is the graph of y equals to sine x. Since c is equals to 0, there is no shift. Okay, now let's have a look at the second example. Y equals to 2 sine 2x. Again, Generally, we can write this as y equals to a sine nx plus c. So our a is equal to 2, the amplitude is 2, and our period is just 2 pi over n. In this case, our n is 2, it's just equals to pi. Because we can cancel out 2 and 2, means that one cycle in every pi. So for every pi, there will be one cycle. And the value of c is equals to 0, no shift. Okay. So when we draw our graph, since they want us to draw from 0 until 2 pi, so as usual, this is 2 pi and pi over 2, 3 pi over 2, and we have the amplitude of 2, so we label that as 2 and negative 2, and we have one cycle in every pi. So for every pi, there will be one s. So remember the graph of trigonometry is very symmetry. Okay, so you can just guess. Since there will be one s in every pi, so we can draw something like that. And for the next pi, one more s. Okay, so the graph will look something like this. Y and x. So this graph is y equals to 2 sine 2x. Now let's have a look at the third example. Y equals to 2 sine x plus 1. Again, the amplitude. Amplitude is equals to 2, and the period is equals to 2 pi over n. In this case, our n is equals to 1. So 2 pi over 1 is just equals to 2 pi. So 1 s, one cycle in every 2 pi. And then we have shift here. C is equals to 1. So it means that shift 1 unit up. Okay. When you draw the graph, since we are going to shift 1 unit upwards, instead of using through scaling 2, you can go up to 3. So this will be negative 1, negative 2, negative 3, here 1, 2, 3, because we need to shift upwards 1 unit. As usual, this is 2 pi, 3 pi over 2, pi over 2, and we are going to have 1 s in every pi. So initially, we are going to draw 2 sine x. So there is only one cycle in every 2 pi. Okay, this is just a rough drawing. And then we are going to shift 1 unit upwards since our value of c is equals to 1. So from 0 goes to 1, from 2 goes to 3, from 0 goes to 1, from negative 2 goes to negative 1, from 0 goes to 1. So you will have your new graph after shifting, something like that. Okay. Okay. So the green graph is what we call as y equals to sine, 2 sine x plus 1. So your final answer should be the green graph. Okay, where the maximum is 3 and the minimum is negative 1. Okay, now let's have a look at the next example. Y equals to modulus sine x. Modulus means that you have to reflect the negative part of the graph to become positive. For every negative part of the graph, will be reflected to positive side. Okay. For example, we have y equals to modulus sine x. Okay. The way we look at here, we try to solve inside first. Then only we modulus. Okay. So again, in this case, our a is equals to 1 and our period is equals to 2 pi over n, which is in this case, n is the coefficient of x. In this case, it's just 1. So it becomes 2 pi. We have 1 as in every, one cycle in every 2 pi, and there is no shift. Okay. Notice that you need to draw from 0 until 3 pi over 2, the value of x-axis, okay, the range of x-axis. So as a start, just draw normally. Okay. So since the amplitude is 1, so I will just label 1 and negative 1. And we have, here is 2 pi. And here is pi. And this should be 3 pi over 2. This is pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. And we have sine x, 2 pi over 2. 1s in every 2 pi, so it becomes 1s in every 2 pi. But then again, we need to shift modulus. So means that every negative part of the graph will be reflected to positive side. So instead of having down here, we need to reflect it upwards, okay, up to the top, reflect it about the x-axis. So it becomes something like that. But if you look at the range required, they require us to draw from 0 until 3 pi over 2, which means that we need to stop at 3 pi over 2. Okay, so which means that we need to erase the right hand side of the final part there. So because the range required is from 0 until 3 pi over 2 only, so we stop there. So we can erase on the right hand side. You don't have to worry because you will be drawing using pencil, so you can just erase by using your rubber. So that is not a big problem. So this is how your graph will look like. So this is the graph of y equals to modulus sine x. Okay. Let's have a look at the next example, which is y equals to negative sine x. When you have negative sign, it refers to reflection about x-axis. Means that you need to reflect top to bottom, bottom to top, as if the x-axis is the mirror. Okay, so let's have a look at this example again. Y is equals to a sine nx plus c. So our a is equals to 1, our period is equals to 2 pi over n. In this case, our n is equals to 1, it's just 2 pi. Instead 1 s in every 2 pi. And our c is equals to 0, so there is no shift. Okay. When we draw the graph, so this is y-axis, x-axis. 1 s in every 2 pi means that we have 1 s in every 2 pi. But then again, we have negative. Negative means that reflection about the x-axis. Okay, so means top goes to bottom, bottom goes to top. You will get something that looks like this. Reflect. So we can erase the previous answer. So this is graph of y equals to negative sine x. The thing is, the range, the domain or the x value, they want us to draw from 0 until 3 pi over 2, which means that we need to stop at 3 pi over 2. So we need to erase the extra part and stop at 3 pi over 2. So this is how your graph looks like. Now let's move to the last example. For this last example, the first thing you need to do is you need to rearrange the equation. So it becomes y equals to negative modulus 3 sine 3 over 2 x plus 1. Okay. And we can see that our amplitude A is equals to 3 and our period is equals to 2 pi divided by n. I like to use the symbol divided because our n is in the form of fraction. So we will have 2 pi divided by 3 over 2. Okay, so it becomes 2 pi times with 2 over 3 becomes 4 pi over 3. Means that one cycle in every 4 pi over 3. And do we have shift? Yes, we have shift. So our C is equals to 1. So we will need to shift up 1 unit eventually. So how are we going to draw this graph? We have to start from inside towards outside. So start from 3 sine 3x first. Okay, the next one you will do the modulus. The third one you will do the negative. And the last one only you will deal with the shift. So start first, second modulus, third negative, and the last one is the shift. Okay. Next one, when we want to draw the graph, you have to look at the period. Period is given by one cycle in every 4 pi over 3. So what I like to do here is I like to draw directly by using the scale of pi over 3. We have pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. Okay, so this is pi over 3. Then 2 pi over 3, 3 pi over 3, which is just equals to pi, 4 pi over 3, 5 pi over 3, 6 pi over 3. So 6 pi over 3 is just equals to 2 pi. Okay. Next one, I will look at the y-axis. Since we have period amplitude of 3, probably it is a good idea if we use the scale of 4, since we need to shift 1 unit upwards instead of labeling up until 3. It's a good idea to label until 4. This is 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Okay, so 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Okay, the next one is when we want to draw, like I said just now, we have to start from inside. So we need to draw the 3 sine 3 over 2x first. Okay, so, and we know that the cycle is 4 pi over 3. So for every 4 pi over 3, there will be one S. Since the amplitude is 3, so the graph will look something like that. And now we will continue to 2 pi. And you don't have to worry because the graph of trigonometric functions is very symmetry. Okay, done with that. The next thing, the second thing is the modulus. Okay, modulus means that anything from the negative part will be reflected to the positive part. In this case, the graph will look something like that. Maximum at 3. Now you can erase the bottom part. Done with the modulus. Next is the negative. So negative is the reflection about the x-axis. So everything needs to be reflected about the x-axis, top to bottom, bottom to top. In this case, everything is on the top and will be reflected downwards. So which means that we will have something that looks like this, as if the x-axis is the mirror because of the reflection negative. So you can erase the previous one. Last, we need to shift +1. Okay, so everything needs to be shifted 1 unit upwards. So it become from 0 to 1, from -3 to -2, 0 to 1, -3 to -2, 0 to 1, -3 to -2, 0 to 1. So your final graph will look something like this. Now you can erase the previous graph. So this is the graph of y equals to negative sine 3 over 2x plus 1. Okay. Okay, in the next video, I will continue with the cosine, the graph of cosine function. Thank you.